Rules of definite integrals. So we've talked about like rules of derivatives in the past, and I guess that might be a good thing to explore a little bit. What are some of the rules of derivatives that we know?
Product rule.
Yeah, we got the product rule, the quotient rule, all that stuff, but just the basic rules, like the derivative of a constant, let's say, is 0. And the derivative of one function plus another function. This one should be pretty basic. What's that? F prime of x plus g prime of x. Those kind of things. And then if I said d dx of other things, this is plus or minus, right? And plus or minus. If I said the derivative of f of x times g of x, that's the product rule. So it'd be f prime of x times g of x plus g prime of x times f of x, right? So this one was pretty intuitive, right? And this one was kind of basic. We understood those. This one, we had to go a little bit more in depth. It wasn't just, oh, f prime times g prime, and you guys struggle with that for, I don't know, 3 months, right? So we're going to start talking about integrals and rules of integrals, and they're surprisingly similar in some cases and completely different in others. Yeah. So rules for integration, and then on Friday we kind of explored a little bit about some of them. Okay, the first one is called the order of integration. Okay, so if I say the integral from a to b, we talked about this on Friday. If the integral of a function from a to b, then that's equivalent to doing what with the limits of integration? If I'm going from a to b, if I flip the limits and I go from b to a, then it's the negative of it, right? And that's what that's saying. Right? And then, so an example. A good way to remember this is that, remember when we're taking the integral, it's kind of like taking the area under the curve, taking the area of a rectangle. But what are we saying? If we go from a over here to b here, which way did I go? In the positive direction, right? And therefore that length, or that width in this case, is a positive value, right? But if I'm going from B to A, I'm going backwards, then what do we say about this width? It's kind of negative, right? It's the width in the negative direction, so we put a negative out front, okay? So negative width implies negative area. So an example would be the integral from 2 to 4 of f of x dx equals 7. Then what could I say as a result?
42.
The integral from 4 to 2 is negative 7. And just keep in mind, remember that the bottom number is the what? The starting point, the lower bound. No, the bottom number is a lower bound. Oh boy, okay. All right. The next one's 0. This one's kind of cool. How do you get 0 for an integral? What'd you say? Okay. The lower and the upper bound are the same. Why would that be the case? If the lower bound is a and the upper bound is a, the integral from a to a of f of x dx is 0. Why? There it is. Because remember, we're finding the area of rectangles in a sense. The width of the rectangle is 0 because we went from a to nowhere. Right? We stayed where we were. So we would say there's 0 width, therefore there is 0 area. Okay. And the example, oh, I don't even have an example. It's that easy. The integral from 4 to 4 of any function is 0. By the way, what is that function inside called? What is f of x called in this case? There's a word. The integrand, right? Integrand? Not the Instagram, no. Snapchat or Facebook or any other nonsense. I don't even know what I'm saying when I say those words, by the way. I just hear you guys say them. All right, constant multiple. If I'm taking the integral from a to b of a constant, so k is a constant in this case, a constant times a function, dx, that is the same as factoring out the k altogether. Remember, the idea of integral is, the idea of approaching the exact area was to slice into rectangles, right? Yes? You okay with that? Yeah. So if I end up with the area of the rectangles as 5 times 15, plus 5 times 22 plus 5 times 7, and so on, right? What could I do to simplify that expression? Factor out the 5. So it becomes 5 plus 15 plus 22 plus 7. And that's kind of what this is saying here. K is a constant, so I can take that out of the integral and then take the integral of what's left over and then multiply it by the constant later. It's the same thing as derivatives. If I say d dx of 5f of x, well, what's that? It's another way of writing that. 5 times d dx of f of x, right? And of course, it'd just be 5f prime, right? Okay. You could do the product rule, but what's the derivative of the first thing? 0. Just know that you can take constants out. And we do that all the time. When we have like 7x squared, to take the derivative of that, we take the 7, move it out, take the derivative of x squared, and then multiply by the same. 7. That's the same thing with integrals. Okay? So we're factoring out from the sum of the rectangles. Do I have an example? I don't think I have an example of this. All right. Are we good with that? Pretty basic stuff, right? The additive property of integration. This one you got to pay attention to, okay? Because there's another type of additive something. And this is one we explored on Friday. If I take the integral from a to b, and then I add to it the integral from b to c, I get the integral from a to c. Why is that? You're finding the area from a to b, and then you're finding the area from b to c, and because there are no gaps, right, then you can just add those two areas up to get the area of the whole thing. Does that make sense? That was kind of an obvious thing. Two things that you have to make sure of to apply this property. What are the two? So in other words, there's no gaps between, therefore, what? Yeah, okay, in a way, you don't want any discontinuity, and I say, what? Yeah, that's kind of the same thing. Two things that we have to make sure. That the upper bound of the first function and the lower bound of the second function are the same values, right? And it does not matter what the other bounds are. If I say the integral from 5 to negative 1 of f of x dx plus the integral from negative 1 to 3 of f of x dx, what is that equal to no matter what? The integral from 5 to 3 of f of x dx. And at first it might seem a little confusing because, well, I'm going from 5 to negative 1, so I'm going backwards. And then I'm going from negative 1 to 3, so I'm going forwards. So that's kind of weird to think about. It doesn't matter. If the upper bound is the same as the lower bound, you can add them up. That's the first thing that you have to make sure. The second thing you have to make sure is what? What are they called? The integrands are the same, right? If they're not the same, this rule does not apply. They have to match perfectly. Okay, and then we would write this, the sum of two adjacent areas, because there's no overlaps and there's no gaps, they're adjacent, is equal to the whole area. So the example, from negative 1 to 1 of f of x dx equals 6. The integral from 1 to 7 of f of x dx equals 3. So what could I conclude there? The integral from negative 1 to 7 of f of x dx equals 9. Easy stuff, isn't it? But you got to make sure those two things apply. Okay. Here's the last one, I believe. The sum and difference rule. It is pretty intuitive. We'll get to the more difficult stuff later on. Don't worry. If you have the integral from a to b, the integral with a lower bound of a and the upper bound of b, whatever those are, of a sum of two functions or a difference of two functions, then you can break that apart. So the integral of f plus g is equal to the integral of f plus the integral of g. Right? That's easy enough. But you have to make sure in this case what? The two bounds are exactly the same. Okay? You're not separating it into two separate bounds. Like in the additive one, we were looking at now you got me, Instagram. We're looking at one integrand, one function, and we are breaking it into pieces of areas. Okay? But in this one, we're looking at two separate functions that compose the integrand. Yeah, okay. And those limits are the same. Okay? So the example that I would give you, so we say, and you've seen this kind of term before, the integral of the sum is the sum of the integrals. Not in the context of integrals, but the sum of the areas. Well, that doesn't work. Never mind. Anyways, the integral of the sum is the sum of the integrals, and that makes sense. If I'm taking the integral of a sum, that's the same as taking the sum of the two integrals. Right? It kind of makes sense. Here's the example. The integral from 1 to 3 of x squared plus 3x dx. How could I break that down?
The integral from 1 to 3 of x squared dx plus the integral from 3 of 3x dx.
But in both cases, in both those two integrals, they had the same limits, right? So it would be the integral from 1 to 3 of the first part of the integrand plus the integral from 1 to 3 again of the second integrand. The limits of integration. Are we good with that? Please keep in mind it's the same thing as differentiability or derivatives. The integral from a to b of f of x times gx, do you think it's going to be the integral of f times the integral of g? No, just like the derivative of f times g is not the same as the derivative of f times the derivative of g. Same thing with integrals. Even more so in this case, the way we go about this problem is actually really more in depth. There's not just a simple product rule. Are we okay with that? Okay, let's do some examples then. You guys see what you can come up with here? I got 2 slides. When you're doing this, though, when you're coming up with answers, don't just put an answer down. I want you to write out any intermediate steps. So I want you to rewrite the integral in a different form so that it matches one of those things or a combination of those things. Don't just say, oh, the answer is 5. And what I mean by writing it out, for A, for example, the integral from 4 to 1 of f of x dx, without even knowing what the answers are up there, how could I rewrite this? The negative integral from 1 to 4 of f of x dx. I know this seems elementary, but it's going to help you later on. Okay, so it's going to be negative whatever the integral is from 1 to 4 of fx. Negative negative 2, which is 2. I want to see those intermediate steps, and sometimes it takes more than one. So A we just did, yeah? I shouldn't have erased it. B, what did you guys get for B? 3. But what's the work associated with that, the intermediate steps? The integral from negative 1 to 4 of f of x dx can be rewritten as negative 1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. Why did you separate it like that? Because I could have done this. Right. Paying attention to what you're given, and if you're not paying close enough attention, you don't know these rules well enough, you're going to try and apply a rule that doesn't necessarily go with the one. Like this rule versus the sum, where the integrand is a sum of two functions. Students tend to mix those two up. Okay? So what's this? Negative 1 to 1 is 5 plus negative 2, which is 3. C, the integral from negative 1 to 1 of 2f of x plus 3h of x. What am I doing here? 3 times dx. Okay, so that's what it is. keep in mind this, and I think I said this before, but when this whole thing is the integrand, right? You don't want to forget these parentheses because then you're kind of implying that dx is only being multiplied by 3 times h of x. You got to have the parentheses in there to represent it correctly, or the brackets, or whatever. So how would we break this down? We'd say the integral from -1 to 1 of 2f of x dx plus the integral from -1 to 1 of 3h of x dx. But even then, that doesn't match any of those, so we have to rewrite this. It's the constant rule, so 2 times the integral from -1 to 1 of f of x dx plus 3 times the integral from -1 to 1 of h of x dx. Then we can work with it. So this first one would be 2 times 5, and then plus 3 times 7. So 10 and 21 is 31. Okay? And then d, remember I just told you, you cannot break that down into the integral from 0 to 1 of f of x dx times the integral from 0 to 1 of h of x dx. That is not allowed. That's wrong. You can't just multiply them. Okay? Since you are starting to feel comfortable with the product rule in derivatives, and you know you can't just multiply the derivatives, let's not have that problem here. Don't try. Right? One more frame, I think, huh? Same thing. Break it down into pieces that would be beneficial. Rewrite the integrals. Oh, these are good ones. All right, you guys got answers for all of them? Did you write all the rules down that you use? All right, A. You're looking for the integral from -1 to 9 of -2 f of x dx. So what rule are we going to apply there? The constant, right? So that's going to be equal to -2 times the integral from 1 to 9 of f of x dx, which is equal to -2 times -1. Is that right? So 2. Okay. B. What rule am I going to use there? I don't know what it's called. Something. Additive? 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 Okay. So the integral from 7 to 9 of f x dx plus the integral from 7 to 9 of h of x dx. That would be 5 plus 4, which is 9. Are you okay with that? Fish food. All right, C. So it's going to be the same type of thing as B, but we're going to take out the 2. So this is going to be 2 times the integral from 7 to 9 of f of x dx minus 3 times the integral from 7 to 9 of h of x dx. So 2 times 5 minus 3 times 4, which is 10 negative 2. Okay. I made most of these too easy, huh? What? Yes, a combination. Thank you. D, what am I going to do with that? What is that rule called? I don't even remember what it's called.
The order of integration.
The flipping rule, the order of integration. Okay. So negative integral from 1 to 9 of f of x dx equals negative 1, which is 1. Okay. And then E is a little bit more complicated, just a little bit, right? Because we notice that we don't have simple things where the limits are exactly where we want them. I want the integral from 1 to 7 of f of x dx Now I'm going to ignore the last one. I'm going to focus on the first two. What? Sure. So if I'm going to combine the first two integrals, I need to make sure that the upper bound of the first one is the same as the lower bound of the second one. So I'm going to rewrite that as the integral from 1 to 9 of f of x dx. What? I guess plus the integral from 9 to 7 of f of x dx is going to equal the integral from what? 1 to 7 of f of x dx. No. This is the equation that gives me this answer. Do you agree? The limit, or the integral from 1 to 9 plus the integral from 9 to 7, since these match, that's the integral from 1 to 7. You guys okay with that so far? Now what's given is not what's there, right? So I have to rewrite this one, so it'll be the integral from 1 to 9 of f of x dx minus the integral from 7 to 9 of f of x dx. Say that again? I'm not looking at what's given to create this equation. I'm looking at E, and I'm rewriting E into a form. I'm rewriting this. Do you agree that this plus this equals this? Yes. Okay, that's all I was doing. Then I'm now looking at this line and comparing it to what's given, and I want to match these to what's given. So instead of saying the integral from 9 to 7, I have to flip it and make it negative so that it matches those. So this one is, the integral from 1 to 9 is negative 1 minus the integral from 7 to 9, 5, equals what I want, the integral from 1 to 7 of f of x dx. So that would be negative 6. So again, we're starting off with the question. We're trying to rewrite it to match what's given. So the integral from 9 to 7 of h of x minus f of x dx. What do I notice about this in comparison to what was given?
The limits of integration.
Both limits are flipped in both f and x, right? Or f and h. So I can rewrite this as, there's a couple ways to approach this. The negative of 7 to 9 of h of x minus f of x dx. And then I can rewrite that as what? Negative, I'm going to put parentheses around all this. The integral from 7 to 9 of h of x dx minus the integral from 7 to 9 of f of x dx. Notice that negative is out front. Okay? So that's negative. What's the integral from 7 to 9? 4 minus 5. So that would be negative 1, which is 1. The other way to do this, I would write it like this. This is another approach. The integral from 9 to 7 of h of x dx minus the integral from 9 to 7 of f of x dx. And then flip all those. So it would be negative integral from 7 to 9. And then plus the integral from 7 to 9 of f of x dx. So we got negative 4 plus 5. So that's still 1. Two different ways of looking at it.